The fourth question here is the velocities of offset point F and G. Okay, the velocity of offset point F and G. So to locate here F and G, again what we will do, we will draw a perpendiculars because we don't know. To locate F, I am writing here, to locate small f, draw perpendicular to BF and CF. Okay, so now here we will take this and we will place presently I am drawing perpendicular to BF here, so I am placing one edge on the BF and I will start draw a perpendicular from B. Okay, and again what we will do, we will place the scale here, okay, on the CF, okay, on the CF, and we will draw a perpendicular from C. Okay, so the intersection point will be F. Okay, the intersection point will be F. Okay, so we can make thick lines here. Okay, we can make a thick lines, and to know the directions here, okay, to know the directions, velocity of F relative to A, you can write here velocity of F relative to A, which is also equal to the velocity, you can write velocity of F relative to B, okay, velocity of F relative to B plus velocity of B relative to A. Okay, so this is also equal to velocity of F relative to C plus the velocity of F relative to D. Okay, so this is also you can say the velocity of F relative to D, because AD are fixed points. Okay, so in vector forms, AF vector is equal to DF vector is equal to BF vector plus AB vector, which is equal to CF vector plus DF vector. Okay, so here the AB vector, you know, okay, you can take this AB vector, you know the direction, and BF vector, so it is in the same direction like this. Okay, and here actually it is the now the resultant will be AF vector, so AF vector will be like this. Okay, you can draw a line like this, so this is the AF vector. Okay, so here you can say the velocity of point F will be the velocity F relative to A or equal to velocity of F relative to D. Okay, so you take a compass and measure this AF. And measure this. So I got 4.9. Okay, so this is 4.9 into 100 our scale, so this is 490 mm per second. Okay, so again what we will do, you have to locate the point G here to get the velocity of point G. So what we will do, to locate G, draw perpendicular to CG and DG. Okay, draw perpendicular to CG and DG. So now we will place like this. CG, okay, and we will move and we will draw a line, perpendicular line from C. Okay, so this is the perpendicular and a DG perpendicular. Actually, if you have a difficulty here, you just fix the paper with something, okay, and then you can move the scale, or otherwise try to buy a mini drafter scale. Okay, so this is the G point. Okay, so this is the G point, and you can connect like this. Okay, you can connect like this. Okay, now again you can draw the vector form. Okay, vector, the velocity of G relative to D. Okay, velocity of G relative to D will be equal to velocity of C G relative to C plus velocity of C relative to D. Okay, in vector form, dg vector will be equal to cg vector plus dc vector. Okay, so here dg vector plus cg vector, cg vector plus dc vector, you know the direction. So now here this is the direction of cg vector, and this is the resultant is dg. Okay, so to get the velocity of g, okay, I am writing here, to get the velocity of g relative to d is a fixed point. So take a compass and measure this dg. Okay, and this is 3.2. I got 3.2. So 3.2 into 100, so 320 mm per second. Okay, so the final thing actually here, the rubbing velocities. You have to calculate the rubbing velocities. Okay, so to calculate the rubbing velocities, actually here directly, if you anyway you know the angular velocities here, so you can use the formulas. Okay, the rubbing velocities at pin A, pin B, and pin C and pin D. Okay, so I'm just doing on the other paper. Okay, so the rubbing velocities, you can say the pin A, okay, rubbing velocities at pin A. Pin A is connecting AD link and AB link, and AD link is fixed, so that you can say it is the radius of the pin into the omega, the angular velocity of the link AB. Okay, so it is the radius of the pin at A will be 30 millimeter. Okay, into the omega is 10, so this is 300 mm per second. Okay, so this is the rubbing velocity at pin A, and at pin B, okay, at pin B, and actually I forgot to mention, actually we have discussed the directions, okay, the angular velocities here. If the link AB is rotating counterclockwise direction, the link BC will rotate in clockwise direction, and also the link CD will rotate in the same direction of the link AB. So that means it is a counterclockwise direction. Okay, so here at pin B, okay, pin B is connecting link AB and BC, okay, so that and both are rotating in opposite direction. Link AB and BC are rotating in opposite directions. So the rubbing velocity is the radius of the pin at B. That means it is 40 millimeter into, because they are rotating in opposite directions, omega of AB is 10 plus omega of BC is 4.77. Okay, so you can calculate this. And at pin C, okay, at pin C, the radius of the pin is 25 millimeter into here the pin C is connecting BC link and CD link. Okay, so both are rotating in opposite direction. So 25 is the radius, and BC angular velocity is 4.77 plus 7.1. Okay, and at pin D, the radius of the pin is 35, and the pin D, actually the link AD and CD are connected, joined. So AD is a fixed link, so the CD is the angular velocity is 7.1. So you can calculate the rubbing velocities like this. Okay, so here you can practice how to draw. Okay, and mostly actually you can fix this. Okay, you can fix the paper so that there is no movement of when you are moving a scale, actually there is no movement of the paper. Okay, like this actually you have to draw for the velocity diagram. Okay, so I will stop here. Okay, thank you.